Greetings, the Astro 30 here yet again with another fun-filled episode of this 15+15 watt stereo amplifier build. Some PCBs have arrived and these are the power amp modules now for this project. So without further ado, I'm going to open the box properly this time. That one there. I must be needing some sort of mental institutionalization.
Excuse me, the f did you just say?
Was that even a coherent sentence? I don't think it was. I meant I need some form of institutionalization because I'm getting way too involved in this now. They've stapled the two sets of PCBs together again like they did the last lot, so I'll just put this box to the side. So the module's in two PCBs as described in the intro of this series. This is the output stage come VBE multiplier circuit board. This actually mounts inside the heatsink and that'll become clear when I actually get the heatsink. There's a hole in here in an attempt to try and get a pair of pliers or a small socket or something in there to do the nut up, or if it was round the other way where the screw went this way, just to get the screwdriver in there. And yeah, there's not much else to really talk about that one. And this is the main PCB and it looks pretty snazzy. So why don't we open each of these packets and have a good look at the PCBs. There they are there. I've got the output stage, well it's pretty obvious it's marked output stage, but the output stage sitting below it and the main PCB up above it. Now looking at the output stage, as we can see quite clearly on the back, it says all transistors mount with metal side facing heatsink. So that's where you mount the transistors on the back side of the board. That's the front. And as I said in the introduction video, I have marked where all the emitter collector base connections are on all three transistors, so you can't bugger it up. Well, you still probably could bugger it up. And the main PCB, it did turn out fairly small, I must admit. I was thinking it was going to be a little bit bigger, but no, it's small enough. And that's the bottom side of the board because we like bottoms on this channel. Yeah, anyway, with the 0 volt or negative rail here common, I've tried to make everything return back to a central point so it's not going to cause issues like picking up mains hum or causing an earth loop or something stupid like that. It hasn't changed much from the original design. I did have a couple of extra components here, but I found that the amplifier did not perform nice with it. I was trying to make a ground lift resistor, like a 10 ohm and a capacitor across it between the negative of the, or the ground connection of the input connection and the main ground. And the amplifier on the breadboard at least didn't like it like that. So I've left that off now. But yeah, that turned out real nice and sexy. So all I need to do is I really need to go out to J-Car and buy the components I need, which is a heatsink, or two heatsinks, fuse clip holder, fuses, and a bunch of other capacitors. And I'll show you when I actually come to do it, but the boards will be mounted like pretty much like this inside the bottom of the case. So imagine there's a 105 long by 75 millimeter heatsink here sitting above this main PCB. So all the connections would come sideways to here. And what I'm going to do with these, even though there's connectors on this board, I'm going to hardwire the wires from this board to connectors at this end. So it's disconnectable here rather than have connectors at both ends. It just eliminates one possible point of failure. And because it's close to the heat sink, like where the heat's going to be generated, I want the best available connection possible. Plus it saves a little bit of money that I don't have to use like, what is it, 1, 2, 3, 6 connectors. I only need 3. So that's what I'm going to do. and by the end of this video this amplifier will be built and it will be tested. Yay! So I'm quite happy to see these. These actually arrived within quicker time than the power supply board did. So yeah. Anyway, let's get to doing something constructive, huh? Okay, I've gone ahead off of camera and I've done all the crimping and hard wiring to the output stage. I've even put the two 0.22 ohm 2-watt resistors on. I haven't put the transistors on yet. I'll wait until I've got to the point of drilling the heatsink, etc., and then I'll do that. It just barely fits inside the heatsink. In fact, actually I'll show you with a blank PCB. No, I won't, because I've put them away for now, so I'll just use the current PCB I've got. This is the heatsink I'm going to be using. It's a JCar Catalog HH8572, and I've made a mistake in my measurement. I thought it was 75 millimeters high. It's actually 72, so there's going to be an overhang. But if we take it out, I grab my output stage board. See, it barely fits in there. And there's going to be about 1.5 mil overhang on either side, but each of the transistors will still mount to this just fine. And when I say barely fit, there's all of about 2 millimeters of clearance between the fins and the actual circuit board. So the tolerance is pretty tight, but yeah, it's not like you have to ram it in there to get it in there. So no, that's good. So now I can put that to the side, throw that in the bin, and work on assembling the main PCB. So I'm going to not take much footage of this. I'm going to start with all the lower profile components, such as the resistors, the half-watt resistors. Then I'll move on to the JST connectors, because they're fairly small in height. Then I'll do the fuse holders, or fuse holder, and probably the potentiometers, and then the larger resistor and the capacitors. And then I'll come back when it's assembled. Alright, I've got the resistors on there. There's only 6 of them, but it took me about half an hour to find where all the bloody things had gone. So I do know I'm going to have to go out and get some more 470 ohms, because I've just used the last 2, because I couldn't find any just lying around. I have used them, buggered if I know where they went. Anyhow, I'm going to move on to the JST connectors now. So yeah, I think I might have put them around the wrong way. What I mean by that is, in this output stage on the connectors, I might have put them in the wrong way around. Let's see. So it goes that way on the board. The green wire is B+. Yeah, it'll be backwards. So I'll put them around the other way so that they're facing the correct way, so I don't have to piss about taking the wires out. Actually, no, I'm wrong. The green wire is being negative. That's on the right, so it has to be that way around. So that B negative is on the left. No, that's correct. Okay, I was a bit confused there for a second. But that's alright, that's pretty normal for me. So I'll just take one in. I'll get the 3-way organised as well. So the red wire is E. And if I put the connector around that way, sorry, the red wire is B, orange wire is C, and yellow wire is E, and that corresponds to the orientation of the socket. So there we go, that one's right as well. Well, I thought I was hallucinating for a second. Probably was. Alright, now I can solder the rest of those in, so it's permanent. Okay, that's the JST connector soldered in. I'll just retouch up that joint. It's better. Okay, I'll put the input one in. Now, I forgot to get some audio cable to make this work to connect to this connector. So I'll just connect the input signal off the end of the 470 ohm resistor at the input here, just to get it to work, to test it. That'll be perfectly fine. So I'm going to get this to. That's hot. Alright, so now I'll solder this one in. Okay, cool. The JST connectors are in, and they're the easiest part to do compared to the other end. Anyway, moving on to, well, I suppose the fuse holder would be a good idea to do next, and then I'll put the larger connectors in. Well, considering it's up in the air in this little jig, it doesn't matter which order I do things in, so I'll go ahead and continue assembly, and then I'll come back when I've completed it. And there we go there, about 45 minutes later, I've got all the components soldered in on the main PCB apart from the main output capacitor, which I want to talk about. I managed to get these on eBay from Tron FX. They're 1000 microfarad, 63 volt, and they're Gemicom brand, but they're only 25 millimeters high, which means it'll fit nicely in the low profile case. I've got two of them because there's two modules. So that's the next thing I'm going to install, well, the last thing on this board, and then I can turn my attention to the output stage, which I still haven't done the transistors yet, but I will do. So put that in there. A lot of noise going on outside. It's a street sweeper. So anyway, ignoring that noise, I'll solder one leg in. And solder the second leg. Beauty. Your mum. Now, I'll cut off the excess leads. And there we have it there. The main PCB is fully assembled. So the next thing I can turn my attention to is the output stage, but I might drill the 3 holes in the heatsink required to do that first. Okay, I got the heatsink drilled, and I thought originally that I drilled it completely off, but that was because I had the board around this way, and as we can see, the holes nowhere near line up. Well, that's for the simple fact that the holes in this PCB aren't directly in the center. They can't be if it fits that way around, because I actually eyeballed it on the back of the heatsink and actually just drew around where the holes were on the PCB to mark out where to drill. And yeah, well, it's perfect that way around. There's somebody at the door. There's somebody at the door. So whilst I was in the middle of doing that and explaining what I was just doing there a second ago, there was a knock at the door and another package has turned up. Now I'm actually quite surprised at how quick this turned up, because I only ordered it 2 days ago. This is my toroidal power transformer for this project. So I will open the box. There's a couple of other components in there too for the preamp, but that's not really relevant to this video right now. Packing peanuts. You ever had fun with these things and hit them with water and watch them expand? They've included a Ultronics Good Gadget Buys catalogue. I might have a read of that later. But there's a lot of packing peanuts in here. Alright, there's my headphone socket that I need. I've ordered the components so I can physically measure them before doing the PCB layout, because their measurements on their technical drawings are sparse at best, and some of them don't make sense. This is a little 9mm 4 position 2-pole rotary switch. Beauty. And in the bottom here, amongst all some other junk, is my transformer. Now it's a Powertran brand 50VA. That gives me roughly 2 amps, 2.1 amps I think it is a current, when both the secondary windings are wired in series. And it's a 12012, so that's 24 volt at 2 amps, thereabouts. So I'll just make sure all the stuff is here. We've got the top cup, 2 insulation washers, the bolt and nut, which is the most important thing, and the piece de resistance, the actual transformer itself. Nice big donut. Donut. I'll take that out. Right, it should be marked on, well, it's marked on the transformer, but it should be marked somewhere what wire does what. And that's how big it is compared to my hand. It's pretty small. So I'm just going to quickly grab the rack case and put it up here on the desk, and I'm just going to make sure that the transformer is going to fit with all its mounting hardware and stuff, etc. That bloody street sweeper. Anyway, that's a positive. The only issue is these wires sticking up, so when the lid goes on it will push them down slightly, but that's alright. But there is plenty of clearance. I'll turn this around. There is plenty of clearance with the top washer, cup, whatever you want to call it. The 2 isolators, there's a good, I want to say probably 2 or 3 mil there. I'll just grab me a bit of wood and we'll have a look. Have a look. Have a look. Oh yeah. Can't really tell from here, but yeah, it's about 3 mil, so that's alright. The only other issue I might have is the bolt itself being too long, which will really piss me off if it is. I don't think it is. I think it'll fit in there. I mean, obviously there's the width of the head of the bolt here, so you minus that out of the equation. I mean, you can always go that way through and you put the nut on underneath. So what I shall do, that really added nothing to the weight of the case. Oh yeah, there's like 5 mil sticking out, probably 10 mil. So I don't know if it's going to clear the feet going that direction. That direction, well, yeah, the head of the bolt barely comes to the edge of this bit here, and that's where the top panel is mounted anyway, so there's an extra millimetre of clearance. So no, it should be fine passing that way up through the case. Okay, well now that we know, I can move on to doing what I was doing, which was actually doing the output stage. Okay, I got a couple of bolts and nuts holding the 2 main TO3P transistors flat with the board, and they're bent at right angles on the rear. I've also got the BD139 bent in, but I'm not going to solder it at the moment. I did go to JCar and get a TIP35C, but it's one of these styles, which is going to be awfully awkward to try and isolate and get a screw through because it's not the right form factor. So that's annoying and a waste of $5.95. So I had to reuse an old one, which I had knocking about. But it still works, so there's no real issue. So I'm going to solder the transistors from the bottom side, so that, because it's just easier and more convenient. And then I'll turn him over, take the bolts out, and then mount it to the heatsink. Because I was trying to do this, mounting it to the heatsink, and all it was doing was the transistors kept on flopping around and falling out. So yeah, that's why I'm doing it this way. That one doesn't want to fall out, so that's fine as it is. So all I've got to do is just get these transistors soldered in, like so, and then I can take it back out of this jig now, and I can play with myself. No, I can turn it over. So yeah, I will cut the excess lead length off in just a moment, but what I want to do is I want to get this married into the heatsink, so I've got to take these bolts back out. Right, I finally got the bloody thing in there. I ended up putting the screws in through the other side because it was easier. So that's the way it's going to mount in the case. It's got feet on the bottom of it anyway, so now I'm just going to check that all the transistors work. I'll make sure they're not shorted to the heatsink. Nope. 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 Okay. I'll just check that. Yeah, that should be PMP, that side. Indeed. That one works. This one should be MPN. That indeed works. Yep, it all works. The transistors are still fine. Now, speaking of works, I doubt I'm going to be able to get around to testing it today because I'm running out of time. I need to get ready for work. But I'll just hook up the connectors to where they go. One there, and that one there. I mean, it's going to not sit straight on the desk, but that's fine. I just want to verify that everything is connected correctly. V plus, E return, V negative, base is red, yes, collector is orange, emitter is yellow, and for the B plus, B minus, blue is B plus, yes, and B minus is green. So the two boards are wired together correctly. So as I say, I don't know if I'm going to get around to testing it today because it's already, I suppose I can. I just need to hook up a power supply. I'm not going to mess around with that toroidal transformer today. I'll just do some preliminary tests to make sure that this thing doesn't go off with a bang. So yeah, alright, well that's the next stage, is to test it. Okay, I got that was the soldering iron. Okay, I got everything set up. I've got the positive connected to positive, the ground of the power supply connected to negative, so we've got 35 volt going in. Just soldered a couple of fly wires underneath so I don't have to make up a bloody cable just to test this. Toroidal transformer's hooked up. I've got the multimeter over there set to voltage across the fuse. I don't know if I mentioned there's a 100 ohm resistor in series with that fuse holder, so we're going to measure the voltage drop across there and adjust the bias at the same time, so I shouldn't need a dim bulb for this. And we've got a pretty good voltage across there, it's not too high, so it's 1.3 volt. Now I want 35 mA, so for 35 mA that should be 3.5 volts divided by 100 ohms. Yeah, so we need 3.5 volts on the multimeter. I'm hoping that this is going to adjust. Indeed it is. It's 2 volts. Too far. I'm going to leave it about there. That should be ample. I'm going to let it sit for a few minutes and then I'll come back and check it. It's remaining stable at around about 3.39. That's close enough. 30 to 35 mA is what we need. Alright, next, still with the safety resistor installed, I'm going to measure my DC halfway voltage point at TP1. If I can get the lead to agree with me. Okay, so we're at 15 volt. Now 35 divided by 2, it's 35 roughly, divided by 2 should be, what, 17.5? So I'm going to preliminarily set the 1 mega ohm potentiometer. Until we see about 17.5 volts, and as we can see it's coming up, so I know that that's actually functioning. So I'll set to around about 17.7 because I'm not sure what the actual DC coming in is. I mean, I could measure it, so I'll take off TP1 and go back to the positive rail. 38, 39. Okay, so yeah, 17.9, almost 18 volt would be about right. I might actually turn that down a bit. So we're not going too high. It'll have to be adjusted on an oscilloscope, which is going to be the next test. I'm going to have to pull the safety resistor out and put the fuse in and somehow get the signal to inject into the circuit. So I'll unplug it for now. And I might have a cigarette and then come back and do that. Alright, everything's set up. I've got a pot in line with the oscillator to keep the input level down because this only requires, I think it was 400 millivolt or so for a full output. Anyway, got that cobbled into the resistor, the grounds and stuff. I've got a piece of heat shrink over the ground of the output so the output lead is not shorting on the ground. Oscillator is on, oscilloscope is on. Now I'm going to power it up. And we do indeed have an output. Look at that. Except we're in ×1 mode, we should be in ×10 because I'm on ×10. So change that to ×10. We're getting 3.4 volt out currently. I'll just wind the pot up. Oh, beautiful. We've got 12 volts so far. Drop that one down. Might use the oscillator instead. And at 29.7 volt, just before clipping, it will start to clip asymmetrically. So where I've set that that 1 mega ohm pot is roughly right, and we're getting a good 30.35 volt out. So we are getting 15 watts. So that's awesome. As for this, it's not getting hot yet. It probably won't either. Because it's a fairly large surface area. So what I want to do now is I'll drop this down till we're about 1 gradical either way of the 0 volt line, and I'm just going to play with the frequency, and yeah, it's starting to roll off at the 4 kilohertz mark, but it's remaining flat everywhere else. Which is that's awesome. I'm very happy about that. Alright, so what that means now is I need to do a sound test. And I think I've got enough time to do that. Alright, everything's set up, audio source and speaker, so what I'll do is I'll plug it in and see if it makes any strange noises. Well, yeah, that's only because of where my grounds are, but that's fine.
What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.
Doesn't sound too bad. Nice, and it started raining outside too. Anyway, now that it's settled down a bit, there's no hum coming out of it. Anyway, I'll work all that out when it goes into the case, where the grounds should be connected and such forth. I've got all the grounds, including the input, coming back to this point, so the output's coming off of this point rather than this point, which is where it really should be coming off of. However, the thing is working and working fine. I can hear all the frequencies are there. It's not lacking in bass. What more do you want? And yeah, and as I said, that 1 megaohm you just set at test point 1 to the halfway voltage point of the supply, and yeah, you'll easily get 15 watt RMS out of it. So I'm quite happy with how this turned out. This particular output stage, the way I've designed it, is fiddly. That's all got to come apart again to put it in the bottom of the case. I've also got to do this again. That means I've got to build all this up again as another module. And fiddle and fart around over here like I did with this one. However, I'm not going to take any video on that because what is the point? You've already seen the video on this one being built. I'll just build it off camera, get it tested, and built and whatnot. So for now, I'm going to unplug it. And yeah, I'm going to end this video here, and I hope you enjoyed it. And if you did, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon member for as little as $1 a month. Links are in the description as usual, guys. Anyway, guys, this is the Astro 30 saying see you later. See you in part 5, where I may do some hardware. Yay.